Okay, again, this one has a video, so let's look at this one. I see a difference of perfect squares. So when I go to label my triangle, I know that my hypotenuse must be 1, right? Because it's 1 squared. And my two legs are x and the square root of 1 minus x squared. So in fact, this same expression showed up in the very first trig substitution problem we did. So maybe this is worth quickly scrolling up. Can I scroll up faster than that? Here we go. This one, right? So in this one, we had the same expression, square root of 1 minus x squared showing up. And so we already labeled our triangles with the 1, the x, and the square root, right? And that was labeled this way so that we could do a substitution of sign. So we're going to stick with that same labeling so that we can do the same substitution. Okay, so that means that my hypotenuse stays 1. Where is my cursor? There it is. And then the opposite side is x, and the adjacent side is going to be 1 minus x squared. Okay, so this gives us a substitution that the x over 1 is sine of theta. So x is equal to sine, and then dx, the derivative of sine, is cosine. Okay, so when I go to do my substitution, x is sine of theta. I need an expression for my 1 minus x squared. And again, we want to just take full advantage of the right triangle. I don't want to have to use the Pythagorean identity. So can I directly find a ratio that uses the square root of 1 minus x squared over 1 to make it easy to solve for that, right? And so that's going to be the adjacent over the hypotenuse. So that's the cosine. So this piece is cosine of theta. And then finally, the dx is cosine theta d theta. So just to be clear here, just because both these things are equal to cosine, we have to be careful. In fact, I was not careful right here. Oh, that's annoying. Okay, so I made a mistake, but I fixed it. So dx, of course, is cosine theta d theta. So, and regular cosine is equal to this expression. So these are different objects, right? This one is a derivative, and this one is just a regular function. So just be careful with that. Don't do what I did. Okay, so we finally have replaced all of our pieces. And just a side note that if you didn't want to do this expression this way, right? You didn't want to do the substitution of 1 minus x squared using the triangle. Remember that you can just use brute force, and you know x is equal to sine, and so you could use the Pythagorean identities to get that this thing is equal to cosine that way. But using the right triangle to your advantage saves you a little bit of work. So now our integral is sine of theta times cosine of theta times cosine of theta, or cosine squared. And so now we're actually set ourselves up perfectly for a substitution. So maybe we'll change colors again since we're doing a substitution now. So a regular substitution, u is going to be equal to cosine, and then the derivative of cosine is negative sine theta d theta. So negative du is equal to sine of theta d theta. That's a sine. Okay, so the sine of theta d theta is going to be replaced with a negative du. Right, so, oh, I guess I am green still. Okay, so cosine squared is just u squared, and then the negative du is my sine of theta d theta. Okay, so let me highlight just to make sure you didn't get lost on that, right? The negative and the du, all of that was my sine theta d theta, and then I've got u squared. Okay, and now we can finally integrate. The antiderivative of this is going to be negative 1/3 u cubed. And now we want to back substitute back in terms of our thetas, right? So this is negative 1/3, and instead of writing u, I'm going to write cosine of theta cubed. But then actually we have to back substitute one more time because we want our expression back in terms of u's. And what is cosine of theta equal to? Well, cosine of theta is equal to the square root. So that's the square root of 1 minus x squared cubed. And so that's our answer.